Imagine the sky turns black at noon. Not stormy, not cloudy, black. The sun becomes a dim gray smudge you can look at directly without squinting. The temperature drops so fast that snow falls in July. You are not standing near an explosion. You are thousands of miles away in a city that was never touched. And yet your world is ending anyway. How is that possible? This is nuclear winter. And the terrifying part isn't the bombs. It's what happens after. You've probably imagined nuclear war before. Fireballs, shock waves, mushroom clouds. But almost nobody imagines what comes next. The part that could kill far more people than the explosions themselves. Could you actually survive it? To answer that, you first have to understand what nuclear winter really is. And it starts somewhere you'd never expect. It starts with smoke. In the early 1980s, a group of scientists, including Carl Sagan, along with researchers Richard Turco, Owen Toon, Thomas Ackerman, and James Pollock, built a model to answer a question nobody had seriously asked before. If cities burned after a nuclear exchange, where would the smoke go? They called their study the TTAPS report, one letter for each scientist's name. What they found shocked even them. A burning city doesn't just produce smoke, it produces soot, fine black carbon particles that rise on the heat of the fire itself. And here's the part that changes everything. That soot doesn't stay low in the atmosphere where rain can wash it away in days. It gets lofted into the stratosphere, 10 to 30 miles up above the weather, above the clouds, above anything that could bring it back down. Once it's up there, it doesn't rain out, it just spreads. Picture it happening in real time. A firestorm rips through a modern city, not a village, a dense, fuel-rich, plastic and asphalt modern city. The fire generates its own wind system, pulling in oxygen so violently that it creates something close to a self-sustaining furnace. This has already happened before in Hamburg in 1943, in Dresden, in Tokyo. Those firestorms were caused by conventional bombs, and they still generated smoke plumes that punched into the upper atmosphere. Now scale that up. Model researchers Alan Robach and Brian Toon later refined the original TTAPS predictions using modern climate models, the same ones used to study global warming, and their results were even more alarming than the 1980s estimates. So what actually happens to the planet? The soot spreads around the globe within weeks, wrapping the Earth in a dark haze. Sunlight that used to reach the surface gets absorbed by the particles high above instead. Temperatures on land could fall by an average of several degrees Celsius within the first year. In the worst modeled scenarios involving a full-scale exchange between major nuclear powers, some regions could see drops of 10 degrees Celsius or more. That's not weather. That's a different climate. Ask yourself what happens to a farm when the growing season effectively disappears. This is where survival stops being about bunkers and starts being about food. You might imagine the greatest danger is radiation. It's real, and in certain zones it would be lethal. But radiation fades. Fallout from most nuclear detonations becomes far less dangerous within weeks as the most unstable isotopes decay. Nuclear winter does not fade. It lingers for years. And a lingering climate collapse targets something far more fragile than human bodies. It targets the global food supply. Robach's modeling, published with colleagues in the 2000s and updated through the 2010s, focused specifically on agriculture. Even a limited regional nuclear war, say, between two mid-sized nuclear states using a fraction of the world's arsenal, could inject enough soot into the stratosphere to cause a multi-year drop in global crop yields, corn, wheat, rice, the staples that keep billions of people alive. Researchers estimated that global caloric production could fall by around 10 to 20% for years following even a limited exchange. In a full-scale war between major powers, some models suggest caloric availability could collapse by more than half. Now here's the question that should unsettle you. You don't need a single bomb to fall near you to starve. Picture yourself in a city that has never been targeted. The war happened somewhere else, months ago. The immediate panic has faded. But grocery store shelves are thinning. Prices for anything imported have tripled. The sky has a strange persistent haze, like distant wildfire smoke that never clears. Your region's harvest came in at a third of what it should have. This is the world nuclear winter researchers describe, and it could reach you no matter where you live. So could you survive it? The honest answer depends less on courage and more on geography, timing, and preparation in that order. Geography matters first. Researchers studying nuclear winter scenarios found that coastal regions, especially those near oceans, would cool less dramatically than inland continental areas because oceans hold heat and moderate temperature swings. The interior of continents, places like the American Midwest, Central Asia, or interior Africa, would see the steepest temperature drops and the most catastrophic effects on agriculture. If you live somewhere buffered by ocean currents, you start with an advantage nobody chose for themselves. Timing matters second. And this is where the story gets stranger. The most dangerous window isn't the first weeks. It's the following 1 to 3 years, when the soot is thickest, when the first harvest failures compound into food reserve depletion, and when global trade networks, already strained, begin prioritizing their own populations over exports. Countries that currently rely on imported food, entire regions of the Middle East, parts of Africa, island nations, would face the sharpest and earliest crisis, according to Robox Team's projections. Meanwhile, nations with large arable land and lower population density relative to food production, like parts of Australia, Argentina, or New Zealand, were modeled as having comparatively better odds of maintaining caloric sufficiency. Preparation matters third, and this is the part you actually have some control over. Not because a personal food stockpile alone would save you through a multi-year event, but because local food resilience, the ability of a region to grow food in low light, low temperature conditions, becomes the real determining factor. Here's something almost nobody considers. Certain crops are far more resilient to cold and low sunlight than others. Root vegetables, potatoes, certain grains bred for shorter growing seasons and cold tolerance. In climate shock modeling done by researchers at institutions studying global catastrophic risk, including work associated with the Global Catastrophic Risk Institute, cold-hardy crop diversification and stored seed banks were identified as among the highest leverage survival factors, not for individuals but for entire communities and nations. This reframes the entire question, doesn't it? Surviving nuclear winter was never really about you alone in a bunker with canned food. It was always about whether the systems around you, the farms, the seed banks, the supply chains, could adapt fast enough to keep entire populations fed through years of artificial darkness. There's a deeper irony hiding inside all of this. The very thing that makes modern civilization so productive, dense cities, global supply chains, just-in-time food delivery, massive urban populations dependent on imported grain, is also what makes it so fragile in this exact scenario. A subsistence farming village in a temperate zone, growing its own food with traditional cold-resistant crops, might paradoxically outlast a wealthy modern city that has never grown a single vegetable of its own. Which means the real answer to, could you survive a nuclear winter, isn't really about bombs, radiation, or bunkers at all. It's about how disconnected your daily life already is from the actual sources of your food. Think about that for a second. Right now, today, do you know where your next meal would come from if global shipping stopped for 18 months? Most people don't. because they've never had to. Nuclear winter researchers have spent over 4 decades refining these models, adding better atmospheric physics, better agricultural data, better climate simulations, and the conclusion has remained strikingly consistent since Sagan's original team first ran the numbers. A nuclear war doesn't need to touch you directly to end your world. It just needs to change the color of the sky long enough to break the systems that quietly, invisibly keep you alive every single day. So picture that black noon sky one more time. The dim gray sun, the unnaturally cold summer. Now realize something. The distance between you and that scenario was never measured in miles from a blast radius. It was always measured in how many harvests away from empty your world actually is.